In this video, we're going to take a look at graphing inequalities on the coordinate plane. In this first example, we have y is greater than or equal to x minus 3. Remember, when we're graphing inequalities, we graph the equation y equals x minus 3, and that is our boundary. That will divide the coordinate plane into two pieces, one of which will shade because that represents the values that work in our inequality. So let's start by graphing the boundary line in this case. This is in slope-intercept form, so we can easily pick out the slope and the y-intercept. The y-intercept, remember, is right here, -3. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So here's our -3, that's our y-intercept. So we're going to start at -3 on the y-axis. So down 1, 2, 3. There's our first point. Then we're going to look at our slope. And in this case, well, what number is in front of that x? That would be our slope. 1 is in front of that x. And 1, as a fraction, is 1 over 1. So that means to get additional points, I'm going to go up 1 and over 1. So here's my next point. Here's my next point, up 1 over 1, up 1 over 1, and so on. I can make all the points that I'd like. Then I need to look at the inequality symbol to determine whether my line is going to be solid or dashed. If it includes the equals, then it's going to be a solid line, because just like this equation right here is a solid line, the values on the boundary, on that line, are included in our solution. So I can go ahead and connect the dots then to get my line. So just going to go ahead and draw that line. Strub it this way. So there we go. Okay, now the coordinate plane, if you notice, is divided into two pieces. There's the part above the line and the part below the line, the boundary. We need to figure out which part contains the ordered pairs, the values, that will make this a true inequality. So what I need to do is do some testing. I can choose any point that I'd like that's not on the boundary, but I like the point 0, 0 because it's easy to work with. So 0, 0 is not on the boundary. 0, 0 is right here. So what we're going to do is take that point and fill in the ordered pair 0, 0 for x and for y. So we have 0 is greater than or equal to 0 minus 3. We simplify and we get 0 is greater than or equal to -3. Now we need to look at that. Is that true? Well, 0 is indeed greater than or equal to -3. So that means all the values on this side of the line will work. So we can shade in this side of our boundary line. Another way that we can know which way to shade is just to look. If it's in slope-intercept form, we can look at it and it says y is greater than. Well, where are the large values of y? They're up here. Okay, as we move up our coordinate plane, the large values of y are up here, so we know that we're going to shade this side of the line. Alright, so there's our first one. Let's take a look at the next one. Get a new coordinate plane going here and switch colors so we can tell apart what we're doing. This one, we have y is less than -1/3 x plus 2. Okay, so again we're going to start by graphing that boundary, which is y equals -1/3 x plus 2, and we want to find our slope and our y-intercept to do that graphing. In this case, our y-intercept, our b, is going to be 2, and our slope is -1/3 right there. So I'm going to go ahead and graph those. So we have our y-intercept of 2 on the y-axis. We find 2, which is going to be right here. Then I go ahead and use the slope to get additional points. So once I've got my 2 there, my blue is not showing up very well. Hey, there it is. Then I use my slope to get additional points. The slope, remember, is rise over run. So we rise -1. Well, that's a down 1. And then we're going to run 3. So 1, 2, 3. And we're right over here. Okay, and we could do the same thing again. Down 1 over 3. Down 1 over 3. Also, if we wanted to go the other direction, if we go up 1, we could go to the left 3. That's the same thing as this, except we put the negative on the 3. So this is also equal to 1 over -3. That gets us in this other direction. Up 1 and to the left 3. Again, up 1 and to the left 3. Now, our boundary line. Well, since in this case we have that y is just less than, that means our boundary line is going to be dashed because we are not including the boundary line in our solution set. So I go ahead and get my line here, and it's going to be a dashed line this time. So we'll go ahead and connect the dots. And there we go. Okay. Now we have our boundary line, so we need to shade. How do we decide which side to shade? Well, it is solved for y, so we could look at the inequality here, and we know that y is less than, so that should mean that we need to shade the lower part. But let's just test that point, 0, 0, just to be sure. So I'm going to fill in 0 for x and 0 for y, so that gives me, not a line, got to get the right tool here, that gives me 0 is less than -1/3 times 0 would just be 0 plus 2. So, is 0 less than 2? Sure enough, it is. Just to be sure, we could check any other point over here. And actually, every single ordered pair that we choose on this side of the line is going to work in our inequality. That's what the graph represents. It represents all those ordered pairs that work. So we shade in this side of our graph. Alright. Now, sometimes the graphs are the inequalities are not going to be in a nice y is less than or y is greater than, that nice slope-intercept form. And it might be easier to use a different form, like we could use the intercepts in order to graph. So in this last example, well, it's not in solve for y form, so I can't easily pick out the slope and the y-intercept, but I can find those intercepts. And remember, we find intercepts by putting in 0 for the opposite of the intercept we're looking for. So if I'm looking for the y-intercept, I'll put in 0 for x. If I'm looking for the x-intercept, I'm going to put in 0 for y. So let's start by finding the x-intercept. That means I put in 0 for y, so I have -4x, 0 in for y here, 5 times 0 is just 0, so that basically goes away, and we have is less than -20. Then solve this, so divide by -4 on both sides. Then we have x is less than 5. Okay, well, when we're working to find those intercepts, we're actually just interested in the equality. So we can just say equals and equals, and our x-intercept is 5. Now we can go ahead and find the y-intercept. Okay, how do we do that? Put in 0 for x. So to find that y-intercept, I'm going to put 0 in for x. That means -4 times 0, which is just 0. So I have 5y is less than -20. Then I can just do equals. We just want the equation part. So I'm going to divide by 5, and I end up with y equals -4. Okay, so now I have my intercepts. Remember, when we're graphing with intercepts, we just find those, and that gives us a point. So the y-intercept being -4 means we find -4 on our y-axis, which is the vertical one. So 1, 2, 3, 4 right there. And there's our first point. Then our x-intercept is at x equals 5, so we go to 5 on the x-axis. Remember, that's the horizontal one. So 1, 2, 3, 4, 5. That puts us right here. Now we've got 2 points. 2 points is all it takes to draw a line. And it's important that we look to make sure we know what kind of line we should be drawing. In this case, it's just less than, so it's going to be a dashed line. So we can go ahead and draw our dashed line. Little something like that. Stretch it out this way a little bit. Okay, so there's our boundary. Now we have to determine which side to shade. Again, the point 0, 0 is a good one to choose. So I'm going to fill in 0 for x and 0 for y and see if that's a true inequality. See what happens. So we have 0 times -4 is just 0, plus 5 times 0 is still 0, is less than -20. 0 is less than -20. Is that true? Well, no, it is not true. So what that means is that we shade the side that does not contain that point, 0, 0. Remember, we put that point 0, 0 in, we tested it, it's right here. It does not work. So that means our solutions are going to be over on this side of our boundary. So we shade in on this lower side of the boundary line. Okay, again, graphing inequalities on the coordinate plane, we can start out by first graphing that boundary line, the equals form of our inequality. Then we determine if it's going to be a dashed line or a solid line based on if it's less than or equal to or greater than or equal to, then it will be solid. If it's just less than or just greater than, then it's going to be a dashed line. Then we need to determine which side we shade. So we do that by choosing a point. If it works, we shade the side that contains that point. If it does not work, we're going to shade the opposite side. I hope that was helpful. Remember, in math, practice makes perfect. Good luck.